Welcome back to another tutorial on decision analysis using Excel QM. In this tutorial, I'm going to talk about different techniques to address decision-making problems. Decision theory is an analytic and systematic approach to the study of decision-making. A good decision is one that is based on logic, considers all available data and possible alternatives, and applies a quantitative approach. There are 6 steps in decision-making process. The first step is clearly define the problem, then list the possible alternatives, identify the possible outcome or state of natures, list the payoff or the gain or loss from the combination of alternatives and outcome, select one of the mathematical decision theory models, and then apply the mathematical model and get the result. Let's consider this example. This is about Thompson Lumber Company, and they want to decide whether to expand their product line by manufacturing and marketing a new product and expand their company. They have 3 alternatives, either building a large plant, small plants, or none of them. In step 3, we want to identify the possible outcome and a state of nature. State of the nature is the future market. Whether the market is favorable or unfavorable, it impacts the selection of each of this decision. We also need to include do nothing because it's also an option. Step 4, list the payoffs. So let's assume that if the company decide to construct a large plant and the market is favorable, they will earn $200,000. On the other hand, if they build a large plant but the market is unfavorable, they will lose $180,000 of the investment. If they construct a small plant, they will gain $100,000 under favorable market, and they will lose $20,000 under unfavorable market. If they do nothing, they don't gain and neither lose. Now, next step is choosing the best criterion to decide which of this option is the best option. In decision science theory, we define 3 categories of decision making. Either we decide based on the complete certainty. So it means that we know the possible outcome and also the future. Here, there is no doubt, there is no technique. We know the decision and we go with that. But there are conditions most of the time that we don't know the future. Either the decision is involved with uncertainty or risk. For uncertainty, we don't know the future and the probability of possible outcome or possible state of the nature. Here, decision is a complete gamble. But if we know the probabilities of each state of nature, then we know the risk of choosing any of the decision or alternative. Now we know the probability, so we know the risk. Now decision making needs courage and it's a gamble. Here are 5 general methods for making a decision under uncertainty. Maximax, Maximin criterion of realism or Hurwitz criterion, Laplace criterion or equally likely, and Minimax. Let's discuss each of them. Using the Thompson Lumber Company example, let's apply the Maximax strategy. In Maximax strategy, we want to maximize the maximum payoff that we can get from the decision. Basically, we want to find the maximum payoff of this decision, and this decision, and then go with the maximum of the payoff. Here, the decision making is optimistic completely, and we are going for the maximum payoff that's possible. So the maximum payoff from constructing a larger plant is $200,000. So between $200,000 and losing $180,000, maximum payoff is gaining $200,000. For constructing a small plant, maximum payoff is $100,000, the maximum of these 2 numbers, and for do nothing is 0. Now we are very optimistic. We choose the maximum payoff, and that would be our decision, constructing a large plant. Maximin. Here is the pessimistic approach. We want to maximize the minimum payoff. So we basically want to find the minimum payoff possible, and among those minimum payoffs, choose the maximum one. So for the large plan, the minimum payoff is actually losing 180,000. For small plans, between these two number, minimum is minus 20,000. So minimum payoff is actually losing $20,000, and for do nothing is zero. So between this minimum payoffs, we want to choose the maximum of them, which is zero. That is max-min criterion. Next one is Hurwitz criterion. So in this criteria, we want to make a balance between being optimistic and being pessimistic. So for alpha percent of the time, we are optimistic, and for 1 minus alpha percent of the time, we are pessimistic. And the criterion for the decision making is basically a weighted average between the optimistic option and pessimistic option. Optimistic option is the best payoff, and pessimistic option is the worst payoff. Let's look at the example. Let's assume that alpha is 80%. That's a weight for being optimistic. For constructing a large plan between 200,000 and losing 180,000, 200,000 is the optimistic or the best possible payoff. This is the worst possible payoff. So 80% of 200,000 plus 1 minus 80% for the worst payoff, 1 minus 80% multiplied by minus 180, that would be 120,000. So for the first choice, the weighted average payoff is 124,000. Similarly, for the small plan, 80% we are optimistic that we get the best payoff, so 80% of $1,000 plus 20% of losing 20,000, so 20% of the worst payoff. That gives us $76,000, and for doing nothing, the weighted average is zero. So we will choose the best weighted average among this option, which is 124,000. This is the Hurwitz criterion or realism criterion. Next method is Laplace criterion. In this method, we basically assign similar weight to this state of nature. So unlike the Hurwitz criterion, which we assigned alpha weight to the optimistic option, here for both of the state of nature, we assign similar or equal weight. So basically we want to get an average over these payoffs. The average of payoff between these two numbers is 200,000 plus minus 180,000 divided by 2. That would give us $10,000. Same thing, the average of these two numbers, 100,000 plus losing 20,000 divided by 2. That gives us 40,000, and for the next one, 0. So between these average payoffs, the maximum is 40,000, and we call it Laplace criterion or equally likely option. Minimax regret is the last criterion. Here, basically, we want to minimize our regret for choosing any specific option. So for applying minimax regret, step 1 is to create an opportunity loss table by determining the opportunity loss from not choosing the best alternative. Second step is to calculate the opportunity loss by subtracting each payoff in the column from the best payoff in the column. And in third step, we find the maximum opportunity loss for each alternative and pick the alternative with the minimum number. Let's look at the lumber company example. So in order to build the opportunity loss table, we need to assume that future has happened and see under each state of nature what is the best decision. So if we assume that the market is favorable in the future, the best payoff would be 200,000 and for constructing a large plan. So that would be the best possible payoff under this state of nature. Under unfavorable market, the best payoff is 0 between this three number, maximum payoff is 0, and we need to do nothing actually. Now based on this two number, we can build the opportunity loss table or regret table. Under favorable market, if we construct a large plant, then our regret would be 0 because this is the best payoff and actually we are making that best payoff. So 200k minus 200k is equal to 0. But if we have constructed a small plant, our regret would be 100k because we could have made 200k by building large plant, but we decided go with the small plant, and now that market is favorable, we realize that we are only making 100k profit. So 200k profit, possible profit, minus what we are earning is giving us the regret. So we could have made 200k, but we are making 100k. So our regret is the difference between these two numbers equal to 100k. And if we do nothing and market is favorable, then we could have made 200k, but we are making nothing. So our regret would be 200k minus 0 equals to 200k. Similarly, if we find that market is unfavorable and we have built a large plant, our regret is 180,000, because if the market was unfavorable market, we could have do nothing and lose no money, but since we have built a large plant in this scenario, we are losing 180k. So this is the regret. If we decide to build a small plant, our regret would be 20,000. That's the amount of money we are losing. We could have a 0 payoff or 0 loss, but now we are losing $20,000. So this is our regret. And if we do nothing under unfavorable market, our regret is 0 because we are not losing any money, and that was the best payoff under this state of nature. Now that we have this opportunity loss, we are looking at minimize the maximum regret. For constructing a large plan, maximum regret is 180. For constructing a small plan, maximum regret is 100k, and for doing nothing, maximum regret is 200k. Among these three maximum regrets, 100k is the minimum. So constructing a small plan results in minimum regret that it's possible in the future. So far we discussed these 5 methods. Let's see how we can address the lumber company problem using XLQM. So in XLQM, there is an option here named as decision analysis, and we go with the decision table. So here we have, let's name it as lumber company example. We had 3 options, 3 decision: small company, large company, and do nothing, and 2 state of nature, either market is favorable or market is unfavorable. Let's click on the regrets table, Hurwitz criterion, and maximizing criterion. Now we have this predefined structure. We can put the numbers here. So decision 1, I can also change the name, large plant. Decision 2 is small plant, and decision 3 is do nothing. Here is favorable market. Here is unfavorable market. If we build large plan and it's favorable, I'm going to just copy paste the numbers from the example here. This is minus 180,000. This is $1,000. This is minus 20,000, 0 and 0. Okay, so the first method is maximax, maximizing the maximum profit. So look at this column. This is the maximum of each of the payoffs. So this is the maximum of this 2 number. Next one is the maximum of this 2 number. Next one is the maximum of this 2 number. And this number is the maximum of this maximizes. So basically this is maximax criterion. Here I call it maximax criterion. We have also max-mean criterion. This is the minimum of the payoffs. Here, this is the pessimistic approach, right? These are the minimum of each of these payoffs, and in the max-mean approach, we want to find the maximum of the minimum payoffs. This is a pessimistic approach in which we are not sure we can make a good profit, but we want to maximize the minimum of the gain. So this is max-mean criterion. Next is the Hurwitz criterion. We can assign any alpha or the weight of being optimistic here. In the example, we had 80%, so let's put the 80%. If I'm 80% optimistic and 20% pessimistic, this is the average payoff that I can get. And basically that is the 80% of maximax or optimistic plus 20% of being pessimistic. And that gives us $124,000. Same thing here, 80% of being optimistic plus 20% of being pessimistic. So this is basically giving us the average payoffs using the Hurwitz criterion, and based on this I can say choose the maximum of this criterion, which is 124, and large plant is our best decision. And if I change this to 50%, meaning that I'm 50% pessimistic, 50% optimistic, then this is changed to the Laplace criterion, and as you can see, the maximum payoff would be for a small plant option. That would be my. And last method is minimax regret. So in the minimax regret, we want to minimize the maximum regret. So here you have the regret table. The regret for choosing large plant under favorable market is 0. The regret for choosing a small plant under favorable market is 100,000, because you could have chosen this and made 200,000, but you choose the small plant and made 100,000. The difference between these two numbers is 100K. And the regret for doing nothing is 200K, because you could have chosen large plant, but you decided to go with do nothing. So instead of 200K, you're earning nothing, so your regret is amount of opportunity loss, 200K. Similarly, the table calculates the regret for you. So look at here, these two numbers are the best possible outcome that you could have under each of the state of nature. This is 0 under unfavorable market. 0 payoff is the best outcome among this, so this is the maximum of the outcome. And then regret is this best payoff minus the actual payoff under that decision. 0 minus 180,000 is 180,000. Now, these are the regrets, and this is the maximum regret for each choice. So maximum regret for large plant is 180, for small plant is 100,000, and for do nothing is 200,000. Among these maximum regrets, we select the minimum of them because we want to minimize the maximum regret. Minimum of these three numbers is building a small plant. In summary, using ExcelQM, you can address all possible 5 methods in decision analysis under uncertainty. In the next section, I'm going to explain decision making under risk.